Hello, this is Bruce Mulch, President and CEO of GreenWize Energy Solutions. I'd like to take some time and introduce you to our GreenWize anti-sweat heater control. We have two models that are in this family of products, and I'd just like to take a few minutes, give you the basic information of what our anti-sweat controls do, how they operate, and give you some information so that you can gather the correct information when you're doing an in-field audit, so that you can accurately predict energy savings and payback for your potential customers. The first product that we're going to talk about today is our flagship product, which is the GreenWize LT anti-sweat heater control. And the LT model has been designed and engineered for glass display doors, reach-in freezer glass display doors. The reason we call it model LT is for low temp. With this particular model, there's two channels, and this is exclusive of GreenWize Energy Solutions, that we've actually taken the energy savings of anti-sweat heater controls to a whole new level by doing something simple, yet incorporating it into a highly technical device such as GreenWize anti-sweat control. The reason that we have two separate circuits within this controller is we actually separate the door heater from the frame heater. And that's important for a couple of reasons. Number one is to maximize energy savings. Anybody that knows anything about energy management is the more control you have over the energy load, the more potential you can save energy. So what we've done is we've taken the anti-sweat heater load, which basically consists of three heaters. You have the door heater, which is actually the heater that wraps around the door frame on each door. So if there's 4 doors in a section of freezer doors, you're going to have 4 door heaters. We also have what's considered the mullion heater, which is the vertical support that runs between the doors and usually has a fluorescent or LED on the back side, light on the back side of it, so that this supports in between the doors, plus it also provides a channel to hang a heater. So that's considered the mullion heater. Then wrapped completely around the outside of the whole 4-door or 5-door section, what have you, is what's called the perimeter or frame heater. So virtually there's 3 heaters inside a freezer door package in reach-in situation. So what we've done is we've created an anti-sweat control that will control the frame, mullion, perimeter heaters with one channel through the control, and then we've separated through the secondary circuit. We're actually controlling the door heaters separate. You might ask yourself, well, why would you do that when everybody else in the industry basically has one control that controls all the heaters? Well, in research and measurement and verification tests, what we found was the door heaters don't need to run nearly as much as the frame and mullion heaters. So by separating the doors from the frame and mullion heaters, you're going to gain significant advantage and increased savings. And this falls anywhere from, on the low end, 15%, and depending on the door package, as much as 30% extra savings by controlling the doors separate from the frame and mullion. So with our anti-sweat, the basic information that you're going to need is you're going to need to know the amperage of what these heaters draw on the freezer case. So step one in evaluating whether the LT is a good application for your customer or not is to identify where the amperage reading really is. And basically there's 2 areas where we find the information. We can find the information on the actual case itself, or the second area is we can actually find the information on the door package itself. Typically the case manufacturer will have either its own door package that they manufacture or an aftermarket package such as Anthony doors or Ardco doors, potentially Styline doors, Gemtron, etc. In the case of Hussmann, recently Hussmann's developed their own door package called Innovator Doors, and they actually have their own sticker on their door package as well as on the inside of the case. So let's break down where you actually find this information. Typically, when I enter into a grocery store and get into the frozen food aisle, and I'm looking for this information, I go to the furthest left-hand door of the door package. And the door package consists of 2, 3, 4, 5, and in some rare cases, there are 6 door packages, but basically what they are is 2 3-door packages put together. They're rare, but they are out there. So if you do find a 6-door package, it's not that uncommon. So once I've identified which door package I'm going to look for the information, I go to the furthest left-hand door, open that door, and up underneath on the ceiling of the case is generally the manufacturer's tag information. When you find that tag information, it'll have information like volts, it'll have probably defrost information, it'll have fan circuit information, and then specifically what we're looking for is what's called anti-condensate, anti-sweat heaters. And next to that, there should be potentially a voltage indicator and an amperage indicator. And what you need to do is you need to take note of the amperage and put it on your audit sheet. And we'll get into the audit sheet in just a little bit. Once you've identified that, that gives you the information that you're going to need to input into your database or your software package that allows you to create and generate return on investment paybacks. So that being said, now that we've identified where the information is, let's make sure that the case is in good enough shape that it actually warrants putting an anti-sweat control heater on it. One of the things that I look for immediately is to make sure, is there any existing sweat on the outside of the case? If there is, I absolutely make a note of it and I point it out to somebody before we start moving forward with the project. Should there be existing sweat on the door package before you start, this product will not take care of that. It will not make that go away. We are to make the door heaters more efficient, not increase heat to take care of existing problems. So please make a note of it if you see existing condensation on the door package before you begin an installation, or even during the process of exploring the opportunity for the customer. The second thing that I note is, are the door gaskets in good shape? If the door gaskets are not in good shape, they're going to be blowing out very cold air onto the door package or the frame area, and what will happen is condensation will begin to occur through the gaps of the gaskets. When that happens, there's virtually nothing we can do other than turn the heaters back on to a full-on state to get rid of those types of situations. Again, not ideal situation for trying to save energy. So make sure that the door gaskets are in good shape. The other thing that I make sure is, are the doors actually shutting? Take the door, just give it a quick pull, let it go. If it falls back onto the mullion and locks in with the magnets on the door gasket, you're in good shape. If it stops 2-3 inches from the actual mullion and the gasket is not making contact with the frame of the door package, again, it's going to be blowing cold air onto the frame surfaces. It will create condensation, and even once it does that, the door heaters are going to take a long time to recover, and there's potential complaints from your customer, and you're going to be out doing a service call. So just make sure that there's no existing condensation. Make sure that the door heaters are working properly and that you're not going to have a problem right off the bat. The second thing that you want to do is make sure that door gaskets are actually in place and are in good shape. And the third thing, again, is to make sure that the door actually closes all the way so that you're not going to have gaps in the door package. So once we've identified that we know the amperage is there, we've got good amp draw, so we know there's good potential for energy savings, we've checked out the case and we know that the case is in good shape, now what we do is we make sure that we put that information down on our audit sheet and we can do the data entry later. So let's talk about where the technology is actually implemented, some quick information on how it's installed, where it's installed, etc. When you get to a reach-in freezer case in the lineup of freezer doors in a grocery store, typically 90% of the time the electrical environment is down below the door package in what we consider the raceway. The first step in identifying where you're going to be putting the anti-sweat control is to take the kick plate off the bottom, which is the cover that's just below the actual door package. There's many different variations on how to open that up. That will basically be up to your installation technician to figure out how to open that up. If you guys do need any assistance on that, a phone call to GreenWize Energy Solutions will help, and chances are we've seen what you're looking at and we can help you. So once we've taken off the kick plate and exposed the electrical environment, that's when we identify how are the anti-sweat heaters actually being powered. And on the newer cases, typically there will be an actual electrical terminal that will have all of the power, and most of it will be identified. There's generally a wiring diagram or a schematic within that electrical raceway that you can use as a cheat sheet, but you need to identify where the heater circuit is actually coming. And this is where you can draw off the amperage that you originally found on the door package. Should the wires not be identified, it's still relatively easy to find the door package and the frame package, because if you find those wires and use a simple multimeter with an amp probe, you can match the energy, the amps being used by the door package with what's on the manufacturer's tag. Compare those two numbers, and if you're within an amp or two, you probably have a pretty good idea that that is the anti-sweat circuit. The other method that you can use is using a voltage indicator and put the voltage indicator on the glass door itself, and by doing such, you can tell when such as this is a GreenWize voltage indicator. Should you guys need these, we've got them in stock. They're under 10 bucks. We'll be more than happy to supply them. But I'm going to tap on this, and you can see there. You can see that it'll actually light up. So when you place this on the glass door, this actually will energize, light up red, and you know that there's door heaters on there. And if you look at our installation training video, you'll actually see this take place on that video. So this is a really good tool to have when you're doing anti-sweat audit. Great tool for anti-sweat audits. Now, once we've opened up the electrical raceway, we're actually going to be installing a power cord similar to this. And this is actually broken down into 5 wires. It's very simple. We've got a black wire that is going to be your power. We've got a white wire that's going to be your neutral. We've got a green wire that's going to be your ground. The red wire is going to be your frame and mullion circuit, and the orange wire is going to be your door circuit. And these wires get tapped into the existing electrical. There's generally no additional wiring that's needed to do an anti-sweat heater control project. Everything is already at the case. It's just a matter of breaking the circuit so that we can start controlling when the power is on and when it's off. And you'll notice on the side of the anti-sweat control right now, there's a green light that's actually on. This is plugged into an actual demo unit, and the demo unit basically comes with just a simple appliance cord so that we can actually demo this in an office conference table type setting so that you can plug it in. So if you need any of these demos, it's a great tool for salespeople to have these. We have these available at a reduced cost because it's a marketing tool. We want you guys to have the tools necessary to sell our technologies. Now, once you've identified your existing anti-sweat control circuitry and you've broken that circuit, this has been installed, now you can actually take the end of this cord, and this actually gets plugged into this part of the anti-sweat control. And it's a simple plug-in. It only plugs in one way, so you don't have to worry about crossing wires. It's very simple. And the reason that I'm going to show you this is we've built in a very quick emergency service jumper that should something happen with the anti-sweat control, if there's any questions whether the heaters are working, etc., it's very simple to get the heaters to be on a full-on position again by simply pinching the two pinchers on the side. You can wiggle the cord out of the controller, bring the jumper, wrap it around, plug it in on the end of the cable, and again, there's only one way this works. So once you get it into position, it locks in place. And once you have that plugged in, these jumpers actually will send power to the anti-sweat circuit 24 hours a day, constant power, until either the controller is serviced or until you identify if there's heater issues or some other external issue with the anti-sweat load. So it's very simple to do this. You don't need tools to do it. Very, very simple. So assuming we are moving forward with the installation, we've got our anti-sweat control powered up. The next step is, once this gets plugged in, now the door heaters are going to be in a normal off position. So your installation process consists of identifying the initial place of condensation. To do so, we actually need the heaters to stay off for a period of time. And once you've identified the initial place of condensation, that's where you're going to need to install the moisture sensors. This is what the moisture sensor looks like. Obviously, it's not going to be installed on the actual controller. We have it on the controller right now for just demonstration purposes. This will actually get mounted on the frame or mullion. That's what's plugged into the frame mullion input. There's another sensor on the other side of it that we've got mounted here. This is your door heater sensor, and that gets put into the door heater input, which is this channel right here. So once we've identified where the initial point of condensation is, it's up to the installation technician to find out the best method for bringing the sensor to that area. Typically, it's taking a 12-inch drill bit. You drill straight down through the fascia area of the case. That enters into the electrical raceway, and you simply thread your sensor through the 1/4-inch hole or 3/16-inch hole that you've drilled. Bring the sensor wire through. There's a simple RJ11, which is basically just a simple telephone clip so that you can crimp that on. That's our communication port. Very simple tools. That plugs in to the controller, and then you mount your sensor on the outside of the case where the initial point of condensation was identified. We also provide you with wire clips so that you can keep the installation nice and neat and tight, and there isn't going to be exposed sloppy wires anywhere. That's critical so that you have longevity in the sensor life as well. So we've identified the anti-sweat circuit, we've identified the amperage, we've got our power cord installed, we've got the sensors on the outside of the case, we know where the initial point of condensations are. Now it's a very simple test to check and make sure that everything is correct, and you can actually do that by simply taking your finger and putting it on the sensor itself. By doing that, it's actually picking up the moisture in your fingertip, creating a change in the resistance that's actually going through the moisture sensor, and it indicates that yes, conditions for condensation are close or very close to appear. We need to turn the heaters on, check the other sensor, make sure that that sensor is working, and basically you have the installation completed and the customer is already saving energy. So that is basically, in essence, the nutshell of the low temp version of our anti-sweat control. What I'd like to do now is we can actually talk about the model MT, and we were actually requested to manufacture this product because a lot of people like to do convenience stores, liquor stores, even pharmaceutical retail, etc. Anybody with a smaller walk-in cooler. This actually provides just as good savings as the LT because there's really no benefit for separating the doors and frames on medium temp or cooler doors. So we've designed a one-channel anti-sweat control that basically there's 2 sensor inputs, there's only 1 relay circuit in here, The circuit will take 12 amps max output, so you can control as many cooler doors as you want with this controller up to 12 amps. And again, let's talk about where you're going to find this information when you identify the cooler that you want to potentially apply the anti-sweat technology to. We'll talk about, and coolers are a different animal than walk-in freezers. Walk-in freezers, generally, there's a nameplate on the door package, there's a nameplate inside the reach-in freezer box itself. Walk-in coolers typically do not have this nameplate information because the box is generally built by somebody, the door package is generally built by somebody else. They put the two together in the field when they're building the cooler. So that information generally is not readily available. However, on the door package itself, you can find the stickers. Sometimes you have to look for them. The worst case scenario is you might have to actually bring a multimeter and amp probe the door heater circuit for the cooler. That's kind of last resort. The other thing you can do is, if you use our general rule of thumb and use 0.7 amps per cooler door, you're going to be relatively close for demonstration and proposal purposes. So on the door package itself, what you want to do is open up the doors and look around the outside part of the door frame itself. Mostly it's either going to be on the top of the door, it can be on the side of the door. I've even seen them where they're underneath the door. So I bring a mechanic's mirror to make sure that I can actually see on top of the door or underneath the door to get that information. There's also going to be what's considered the frame heater sticker, which you need to find that and identify that on the actual frame itself. Now, this can actually be between doors, it can be on the side of a mullion, it can be on the outside part of the frame area, so you have to kind of do some digging, and we'll supply you with some examples of where these stickers are located in follow-up materials. So once we've identified the amperage and we know what the potential energy savings is on the cooler, again, you're going to want to do the simple steps to verify and make sure that you pre-qualify this cooler as a good opportunity for your customer. One, make sure there's no existing sweating. This product will not make existing sweating go away. If anything, it could compound the problem. Second thing is make sure door gaskets are decent. And third is make sure that the door is actually shutting and sealing against the door frame and mullions, etc. So once we've identified that, we've identified it's a good opportunity, we've gathered the amperage information, we know that there's enough amperage to make sure that there's a good payback, we can proceed with the installation. To do the installation, this is a little bit different than the model LT when we're talking reach-in freezer doors. We're actually going to be installing this product on the inside of a walk-in cooler or walk-in freezer. There's typically a conduit run that's above the door package that daisy chains power to each set of the door sections. The J-box is generally located on the far left door. You identify the first J-box, that's the one that's supplying power to the rest of the doors. That's generally a good spot to install the anti-sweat control. It's a simple matter of taking the J-box open, identify the anti-sweat heaters. We're going to be using a little bit different cord for MT than LT. And on this cord, it's basically the same. You're going to have your black wire. You've already seen the wires. We don't need to get too technical on this. But basically, there's 4 wires. Black is your line, white is your neutral, green is your ground. And we only have 1 wire for output, which is your red wire. And that's going to control frame, mullion, and your door package through 1 circuit. And again, you're not going to lose any energy savings because in a cooler application, you just don't gain the benefit of controlling the door separate that you do on a freezer application. So typically what we do is the installation is we open up the J-box, we feed the wires through a knockout, we've got an NM connector that holds the wire in place, we identify the anti-sweat lead, we break the circuit. The rest of the installation is very, very similar to the LT. Once we have the cord installed, we plug the controller in, we identify the best place to install the sensor. Again, this is information that you can see in our installation training video, where the best place to identify sensor location for MT applications. You install the sensor, and before you leave, you want to make sure that the controller is working. And again, it's just a simple matter of putting your finger on the sensor, and you'll notice that the red light is lighting up, indicating that the controller is active. We've got green power. We know that the unit is up and running, and we also have the red light cycling on and off, so we know that the heaters are working. One thing that I do recommend to the installation people is to check and make sure that the amperage that's going through the controller matches what you identified in your audit, so that we know that we've captured all of the anti-sweat control load and that we don't have any loose connections, because that would lead to a service call later. So that being said, that's our introduction to our anti-sweat controls. And if you have any further questions, please contact us at either info@greenwize.com, or please call us toll free at 877-682-1301. We'll be more than happy to answer any questions that you have.